Welcome back. Folks, here is the official Computer Science Department and Information Technology Program book bag. When you come into the department through those glass doors, you may see this is our little logo there. And it's probably not obvious what that's all about, so I will just share it with you. As a matter of fact, I just did share it with you, the three components of a system. It's supposed to represent hardware, software, people. So the ones and zeros for the software is supposed to be like a little integrated circuit. And that, I know people say, that's an eye. Well, I was kind of hoping when the graphic artist did this, that this would be a body, be a little bit wider. But that's supposed to be a person there, too. Okay? So now you know. Are all the words spelled right? Computer Science, Information Technology, Concordia University, Wisconsin. I think so. Good. So if yours got messed up, let me know. If you happen to be taking this course at a distance and want one of these, then send me a self-addressed stamped envelope. No, I'm just kidding. Ask for it and I'll send you one. Okay?
Actually, the eye is too significant. When you're looking at it, it's me.
Ah, pretty good. I like that too. See, there's things you didn't even think of. So the I could be you. The I could be for IT. Yeah, whoa, that's pretty good. Do I don't have to pay anything for that, do I? Okay, good. Okay, folks, back onward here. Oftentimes during the second hour, I would talk about homework and set. We will do that, but we'll do it next time. Let me just get at least started through the rest of some of these things in the body of knowledge. Won't spend as much time with each one because you'll experience it, but just so you know the kinds of things that are important, the kinds of things that will be coming. This class, by the way, the other thing you should be aware of is there are certain courses have certain other courses as prerequisites. For example, this class, CSE 505, is the prereq for every other course higher numbered. So to take the 10 course, you have to first of all complete the 5 course. The 10 course is also the prerequisite for our foundational programming course, the 35 course. So before you could take 535, 835, you have to complete this one here. I always recommend to students that you take this course earlier rather than later in your program. When we initially designed the curriculum, if you followed it in numeric sequence, then everything would work out. You'd have all the prerequisites. But you don't necessarily have to. You can jump and skip around. Some people, I'm trying to think of a high course without a number of prerequisites. I have to look it up. But there's no reason you couldn't take CSE 540 perhaps next just with 505 if that's the only prerequisite. When you're thinking about scheduling and what might be coming next, then just also note that some classes have others as a prerequisite. Every once in a while, I run across a student that's, they're in the last semester and they want to do this one earlier rather than later. Okay? Thank you. So what else do IT professionals need to know? By the way, I agree with all these things. There are some things perhaps in the body of knowledge that I think are less important, so obviously I'm not putting them up here. But the ones that are here I absolutely agree with. An IT professional needs to understand user needs. We solve problems when our users solve problems. The way that we're going to measure our success is by how well our users can actually solve problems. To tell whether a system is successful or not, don't ask the IT professional. She or he will most likely say, oh yeah, this is a real successful system. Ask the person who has to use the system, whether it's good or bad, right or wrong. Right? We have a course specifically dealing with this, and then again you're going to see this in many courses, including this one, the centrality of user needs. One way that I usually express it is through this concept, user-centric design. User-centric design. What the heck does that mean? It means putting yourself in the user's position to determine needs wants, features, functions, anything else about a system. Put yourself in the user's perspective to determine needs. IT professionals, we understand technology. We're going to be very good at solving problems. But we are not an expert in the problem domain necessarily. We solve problems for other people. If you were asked to create supply chain, something or something in retail or something in healthcare, obviously I don't know anything about it because I can't even think of an example. If you were asked to create some system in healthcare, for example, a patient monitoring system, well, we can do the technology well and right, but if we only relied on our own expertise, the system we'd come up with would not be usable because we're not the healthcare professional who's going to use it. See, the healthcare professional ought to have the input into what's needed in order to solve the problem. I see too many systems that are kind of designed this way for no good reason, and it's force-fit onto the user. Is it designed in a user-centric way? Are we thinking about the user's needs? Another way of expressing that is to be a user advocate. An advocate is someone who speaks on another's behalf. So we need to get into the mindset of being able to speak for the user. Oftentimes users are not part of the development team. Oftentimes the folks controlling the money don't consider having users involved here. But someone needs to recognize that the user are going to have specific needs, and those needs need to be satisfied to have a successful system. I know you've experienced poorly designed systems. At least I have plenty of them. Right? Systems that are just convoluted, unusable. It doesn't have to be that way. You can't. It is possible to find out what the user wants and then provide that. Now, it's pretty simplistic. We'll talk about that in another class. But somebody needs to speak up for the user. And that should be us, because they're not the technologists. Can you think of a product, a system that you use, be it software, hardware, whatever? Can you think of a piece of technology that is good? You said, wow, this is really nice. I could figure this out. This meets my needs. It was designed in a user-centric way. Windows. Okay. Why did you say, I don't want to dispute any of this, but I just want to get a little deeper on why people said that. Windows. Why?
Because Windows makes execution of something easier by just clicking on it.
Ah.
Right?
Okay, exactly.
Because otherwise you would have to execute so many commands
Yep.
to achieve the same thing.
Yep. Okay, good point. So the idea of a more visual metaphor, the idea of just being able to logically at least point at, that's what I want there, okay? Now, of course, originally that was done with a mouse, although actually Hewlett-Packard, we had a touch screen in the 1980s, and you could just touch things there for that. That seems, yeah, usable, okay? Windows and that whole general user interface metaphor seems to be a good user-centric design. Good. Other examples? System, an app. Darn it, had to be more than one. I'm sure there are, right?
I like some website about clinics.
Okay.
Healthcare.
Okay.
My area.
Oh, okay. Mm-hmm. Yeah.
It's easy to make appointment, talk to the doctor,
Okay.
send a message.
All right.
Just download.
Uh-huh. Okay, good. So,
Easier to contact with the clinic
Sure, sure. So this healthcare information website, My Aurora, okay? Is that what I use? Are my doctors in Aurora? I'm sure there's something like that. So you can then access, and then you can look up and see, here's the results. You know, you went to see your physician, and they did some tests, and here's the results. Schedule an appointment. Yeah, right. It's oftentimes much easier there. And if the user interface is set up in an understandable way, then that makes life really nice. There are probably plenty of websites that aren't set up in a user-centric way, but that might be a very good example of one. Good. Other examples.
User-centric. iPad is probably.
Okay, yeah, sure. Okay, tablet computing, and that whole metaphor of gesturing that came along with that seems to be, I don't know if intuitive is the right word, but seems to be in tune with many user needs. Okay, yeah, very cool.
So I think automobiles these days are very user-centric.
Okay.
With all the navigation,
Yeah.
with all the technology that tells you
Sure.
diagnostics of cars. And
Okay.
stuff like that. That's
Yeah.
very user-centric.
Yeah, very good, because it doesn't have to be a classic computer. So there's lots of technology in cars, and the things focused on that, whether it's GPS or,
YouTube.
yeah, exactly, the connectivity, so you can stream your tunes. That's important.
And Skype.
Skype?
Messages.
Okay. And do you find Skype is it inherently useful, or is it, do you think it's easy, in other words, designed in a user-centric way?
It's easy.
Okay. Okay.
Like,
Yeah.
how do you find it?
Yeah. I mean, it's very straightforward, right? Right. I mean, there's not a whole lot there, right? Thankfully. Sometimes you have issues configuring, and of course, if you have communication issues, that's not necessarily the fault of the system itself. That's another problem. But yeah.
If you have a good Wi-Fi, then you wouldn't have a problem with the connectivity.
Okay. Right.
That's
Right.
it.
Yeah. Exactly. Okay. Yeah. Good example.
Probably all the time ATM.
Okay. You think so? You think an ATM is really user-centric? Okay, maybe some are. I don't know. You know, it is kind of funny. When I was a graduate student doing data security at UW, the most paranoid person I ever knew was the data security prof, who was a well-known, George DeVita, kind of like a big name in security. And although this has been, admittedly, a number of years ago, I mean, he would not do electronic banking. I mean, I'm not sure he had credit cards. Okay, ATMs. Oh man, after he went through the horror stories with ATMs, I mean, I probably used an ATM 3 times in my life. Okay, isn't that weird? But yeah, so okay, I wouldn't know if they're user-centric or not. All I can tell you is the litany of problems with.
You touch on banks, okay, with all the features. Now, is there a difference between user-centric and ease of use?
Ah,
Right?
yeah.
I think there is.
I would think there is too. Why don't you explain what?
Okay, so for example, the banks have all the websites for all banking now. They try to be user-centric by allowing you the ability to do things yourself without going to the bank. But it's not necessarily easy to use if you don't know how to use it.
Yeah.
Right?
Yeah.
So I
Exactly.
think there's a difference between
Okay.
user-centric. They can try to be as user-centric as they want to be,
Okay.
but if it's not easy to use, then you can probably end up losing your money somewhere and you can't find it.
That's a very interesting comment. And as, of course, as systems get more ubiquitous, as they are, everywhere. Yeah, good comment. I'll think about that some more. I'm going to give you the opportunity to answer this question with a very specific system, and that's Angel. I'm going to ask you to, as you're using Angel, it's probably a good test case because for most of us, and I'm hoping almost all of us, this is a brand new experience. I mean, you may have done other learning management systems and that kind of, but Angel is probably something brand new. So I'm going to ask you, as you go, do I have this? Yeah, here it is. I'm going to ask you, Angel. I can't tell you how many people don't know what that does. But anyway, let me not sway you one way or the other on this. One of the assignments for this unit is, I'm going to ask you to answer that question. And the way to do it is just keep a record. It doesn't have to be formal or anything, but just, jot yourself little notes or speak it into your phone or whatever it is there. Because when it happens to you, you'll lose it if you don't kind of record it as you're going along. Right? And I'm going to ask you an assignment. It'll be due several weeks out now. I want to make sure you have plenty of time to actually interact with Angel and find all the both positive and negative aspects of it. Sometimes people assume something. I'm not sure why. Many times people assume that I love Angel. Now, I want to make this very clear. I'm not going to tell you whether I love it or hate it. But I didn't specify Angel. I didn't choose to use it. That was the system that our IT support department chose for us. Okay. So I have no vested interest here. You will not hurt my feelings. If you say you love it, that's fine. You say you hate it, that's fine. And actually, I care less about that than finding out, do you believe that this was created in a user-centric way? Critique the system. Critique doesn't necessarily mean to find fault. It means to critically analyze. So don't just, for example, don't just say, oh, it was good. It was user-friendly. Support that. Explain why you thought that. How is it that way, etc. Okay? It's one of the assignments. I forget which one. We'll look at them all, and then you'll see it. We have a course in our curriculum, the 20 class. Human-computer interaction. Boy, this could be 12 courses. It could be an entire master's program, and in some places it is, the human factors curriculum. I'm lucky that I have an expert, really a world-class person in Professor Bainish, who has done this in industry for many years and teaches this course for me. He currently works for Kohler Corporation as an IT specialist. I'd be remiss, I need to go back because I didn't tell you, I also have a world-class person, and I don't use that term lightly. Dr. Angus Manouge, who is chair of the philosophy department here, also teaches for me in computer science. And he developed and oftentimes teaches this course. And he speaks around the world. He's a well-known philosopher. He's the current president of his philosophical society. So, that's kind of cool. There's some real interesting stuff there. And as grammatically poor as that sentence was, it's still good. Okay? Same here. I'm really happy. We've got a lot of really good faculty members here doing some very interesting stuff. Yes, tech support. My laptop kept freezing up, so I stabbed it with a knife. What do I do now? I probably can't show you this cartoon. I think campus safety would probably say something about knives and weapons and stuff. Okay. Interestingly, I think if I gave you a big list of, or at least these 10 things that I was going to share with you today, and asked you to rank them, most of us would probably put this number 1. Now, it's not that this is not important. It is important. It's not like you only have to know 1 and you don't care about 2, 3 through. No, they're all important. Right? Problem solving. Dilbert, meet our new account manager. Hi. His job is solving a hodgepodge of problems that would bore a normal person to death. We think his parents didn't let him have toys. The first days are the easiest. Okay. Solving problems in IT, we know, this is kind of central to what we're up against. and we know it's a long road, and you know I'm not going to tell you today in 5 minutes how to do it, right? I want to illustrate a couple things, though. Imagine that I asked you, I gave you a list of numbers, and I asked you, find the biggest value. Could you do that? If I gave you this list, you could just inspect it. And you could tell me instantaneously, just by inspection, what the biggest number is, right? Oftentimes, we solve problems, and we don't know exactly how we do it. An IT professional should not suffer from that disease, because an IT pro should always be thinking algorithmically. See, if I asked a bunch of could you find the, they'd say, yeah. So then I say, okay, imagine this is a list of 10,000 numbers, or imagine this is a list 10,000 pages. How would you do it? Most people are not sure how they go about doing it. Okay? I mean, and really when I talk about this, I do this in an undergraduate class. I have people, oh, I found the biggest one already. It's 937. No, that's not it. Oh, look, 950. No, that's not it. Okay? Yeah. I think as an IT professional, you already know one of the big keys to solving problems, and that's to think algorithmically. Think in terms of precise instructions for solving the problem. See, it's kind of hard when you have a small problem to even think about how you do it. I mean, most experts, when asked, how do you do the things that you do, they have a hard time explaining it. They have internalized the process. It becomes sort of second nature, and it's hard for them to explain how they do things. But for us, we need to think about scalability, right? I'm never going to approach that unless I have an algorithm for this that I can scale up. Now, I think you know what that is. So, what is an algorithm for finding the largest value in a list? Well, you remember the biggest value. I should probably add so far. Remember the biggest value so far as you look through the entire list. That's a valid algorithm to solve the problem. And it is what we're doing, I think, although a lot of people are just scanning that randomly, right? Why are they scanning that randomly? Because that's how they solve that problem. And although that works, you know, our perception works well with a small problem, it doesn't scale up. I want you to just run your eyes across 100 and now 10. No, it doesn't work. So the algorithm, again, remember the biggest values, you look through the entire list. Okay? And sometimes it's hard for people to get started. Well, what's the biggest value? Well, it's the only one that you've seen. Okay? So now I'll just remember 53. And then, you know, there's something else that was implicit in that wasn't stated. I then need to compare the next value to the biggest so far. Is it bigger? Nope. Compare the next to the biggest so far. Is it big? Nope. Compare. Aha! That one's bigger, so I'll remember this one so far. Now, of course, as an algorithm, this requires a lot of different stuff. The assignment concept, logical operations, and so it goes. But to begin to think about problems algorithmically is certainly the way to solve problems as an IT professional. Now, that will scale up directly. 287, the biggest so far. Well, wait, 365, that's bigger. 160, no, 584, yeah. Now, see what trips up people is they say, well, it's going to take too long. Take too long for you and me. What about a computer? That won't take too long at all, right? That won't take too long at all. We can easily scan 10,000 values sequentially in a blink of an eye. Okay. a fourth thing that most IT professionals and companies and hiring managers look for is, can you use the tools of IT? And by this, we mean things like some of these technologies in this book here. Am I really expecting you to be a Java expert? No. Am I really expecting you to understand Linux through and through? No. Okay. But you need to know how to use tools in general, and you should know a few tools very well. I'll just pick on programming as an example because, again, when I was out visiting various companies in the fall, I was really more interested in some issues dealing with programming, supporting my undergraduate curriculum in software engineering. And so I knew what the answer was. I was pretty sure of the answer, but I'd always ask, first of all, I'd say, well, what shop are you? And by that I mean, what language or environment do you work in? Are you a Python shop? Are you an Objective-C shop? What language do you use? And they'd tell me, and then usually before I can ask the next question, they'd volunteer. But you know what? When we hire people, they don't have to be experts in X. Really? That's right. You see, what they want you to be able to do is solve problems well, think conceptually, algorithmically. Now, does it help to know a specific language? Sure. But most organizations want you to get into their mindset, so they would just assume that you not come already thinking you're an expert because they'd like to help develop your expertise. That's the model we've always followed here. I don't care what language we're using. Now, if we use something bizarre, well, okay, if we use Fortran, I mean, most people say, what? Okay. So undergrads, we use Java, C#, and Objective-C. They're pretty standard languages. I mean, they're not what people would consider state-of-the-art. They're not like Python or Sally or any of these other weird things like that. But, you know, they're good enough. But the point is, if you understand that model, if you understand that tool, that skill will transfer. You'll be able to pick up another language in another paradigm fairly easily. Okay? This pie chart just lists somebody's idea of recent projects, and this person I think is skewed a little bit because he believes that Python is used in more than anything else, and for some reason has a very large JavaScript thing here too. Not buying it. Okay. There's a course in our curriculum, it's the 35 class. Funny title, System Development Theory and Practice, where you are going to do programming a lot. Only and always. It's taught by Dr. Lippman. I've used world-class 2 other times now, and this is true of him. I mean, he is a world-class programmer. Not only did he have one of the very first apps on the Apple's App Store, but he had one of the highest grossing apps originally on the Apple App Store. He can probably program while asleep. Okay? He is, yeah, far and away, I mean, much, much better than me. No question about it. So you're really learning from one of the best. And the other neat thing about him is, you know, sometimes people are expert programmers, they can't explain that to anybody else. Yeah, he can teach it too. That's pretty unusual. If you find this interesting, by the way, we do have another course and then a third one in the works. So we have a Programming 2 course. It's the 37 course if you find this kind of stuff really exciting. We're all going to do a little bit of, I don't know what language he uses either. Might be Java, might be something different. If you find that interesting and exciting, we got more. Oh, by the way, here is an example. We have several of these in the curriculum. I didn't put the next course, the 37 course on, but it probably makes sense, right, that before you take the 37 course, which is System Development Theory and Practice 2, that you have to complete that class, right? Yeah. This is a prerequisite for the 37 class. Your brain sucked dry. Please insert next programmer. You're going to feel like that when you start doing that. Now, along with this idea of tools, a programming language is certainly a tool, and another common tool we use is database systems. We have another required course in the curriculum. Every course I've shown you so far is required, and that's the Database and Information Management course. You have to take at least one course in this, and we have a follow-on and another one in the works. So there's a 32 course, the Database 2 course that follows on with this. And again, it's a real sharp person. I've said, now you're going to say, why don't you say he's world class? Because I'm overusing that. Okay. My colleague, Professor Wall, did database in industry for quite a few times, and this is his area of expertise. And I'm really thankful to have him with us. Database information, just another tool to help us solve problems. I found a match at the store on 5th and Main. It should be close enough to fool your daughter. See the dad with the dead goldfish and the goldfish database. What car company is that? The car company commercial, the guy is racing across town with the goldfish, dumps it in the bowl just before the daughter gets home. This is sort of a running gag, isn't it? Okay. Another thing that's commonly asked for by both the body and knowledge and other IT professionals is IT professionals need to know how to troubleshoot, how to solve problems that arise during the day-to-day operation of their systems. This is a little bit different than applying and managing the technology, right? This is maintaining it. I shouldn't say that. This should be part of managing the technology for sure. But just all those issues that arise seemingly moment by moment, come up all the time, something goes wrong. Can you troubleshoot? Can you methodically determine the problem and implement an effective course of action? I think we've all done this, right? Ever had something go wrong with a piece of technology? Never. No, me neither. So let's just dream some things up. Examples? Anybody have an example? You've recently, something went wrong. Own computer, computer at school, computer at work, technology here, there, or otherwhere. Oh, and then I'm going to ask you how you solved it.
I had a problem with my keyboard.
Okay. Wow.
The key isn't working.
Yeah. And so what was the problem?
I went to IT support.
Uh-huh.
They said you have to change the keyboard.
Okay. All right. I have a problem with my keyboard. Yes. How do I fix it? Get a new one. Okay. All right. Yeah. Do you know that, interestingly, in the bad old days, the dishwasher was the common method of fixing keyboard problems? I mean, literally, people would put them in a dishwasher and rinse them out, and sometimes they'd work. Weird. Weird. Okay. Help us, Pat.
A recent problem I had is one of our schools, they use a website with their students. It's Flash-based. We're using Macintoshes. One series of Macintosh had this version of operating system, and another series of Macintoshes had a different series or newer operating system. What ended up happening was a couple of things. First of all, on the older Mac, the older operating system, with a certain version of Flash, they were getting to the website just fine. The program was playing, the kids were happy, everything worked. The newer Macintoshes, even though they had a newer version of Flash on it, they were no longer working. They wouldn't play correctly. Some of the methods I used to troubleshoot the problem and help correct it was one, through everything that goes out on the internet gets filtered. It's a content filter. One was adding exceptions through our content filtering to make sure that wasn't impeding information coming back to the computers.
That solved most of the problems. The other problem was on the newer computers, there was still some functionality missing, and it turned out that they had to downgrade the version of Flash to make it compatible with the site that they were going to. So the site they were using just wasn't using the newest features.
Right.
So that's
Yeah.
pretty complex one.
Mhm.
So I'll give you a really easy,
Oh, good.
simple,
Good.
everyday problem.
Uh-huh.
Recently, I had a flat tire, and I had the flat tire repaired, and my car was running fine. A week later, I was losing air, right? So the monitor comes on.
Okay.
Okay, I'll just go put some more air in. Maybe they just didn't put enough air.
Uh-huh.
You put some more air in, waited a week, went back, right? Then I figure, well, let's try something, So I went and bought one of those things that you put in the tire where it seals up
Yeah.
the tire,
Yeah.
right?
Slime.
Right.
Yeah.
So that solved the problem. So it's a process
Okay.
of just, find things,
Right.
see what works.
Right, yeah. It was a process of, and both of these are illustrate, you need to analyze the problem and then in some methodical fashion try to apply some potential solutions to it. Yeah, good. Good. I like that. I don't like flat tires, but car analogies are good. I like this. Troubleshooting is just part of the world for us. I mean, I'm involved right now with the issue in our network. We have, next door in the lab, we have 25 machines, and of course, in order to keep things updated, we don't want to necessarily go around to every machine, so we use a common type of product that will allow us to clone, make an exact copy of an image of a machine and push that out to the other machines. Product we currently use is something called Deploy Studio. Well, some changes to the network infrastructure have resulted in our product not working. And we've methodically tried many, many different things. We're at the point now where we've made as many changes to network configuration as we think are reasonable. So my next step now is to not go through the network, but actually hook two machines together directly and see, which would tell us if that works, there's some kind of network infrastructure problem. If that doesn't work, then that means we just have something misconfigured on the server there. Okay, sure. So I'd like to tell you that the world of IT is very glamorous and people work on very interesting things all the time, but every once in a while you got an old version of Flash or a flat tire that that's just sort of what we do too, right? Exactly. We do have a couple courses that are going to focus more on some troubleshooting techniques and ideas than perhaps others do. Truly, a lot of troubleshooting is experientially based, so the more experience you have, the better you'll be at it. But one of the courses, the 50 course, System Admin and Maintenance, is also focusing on some troubleshooting aspects, especially in server administration and, well, I shouldn't say networking because we have a separate class for that. The 50 course, this is the first course that I've mentioned that is not required. It is a possible elective in the program. And secondly, it is logically the second course in a 3-course sequence, so it has a prerequisite. The 45 course must precede the 50 course. The virus is that bad, huh? Yeah, sometimes troubleshooting requires these neat special hazmat suits, too. Okay, maybe not. Maybe not. Another thing we hear consistently is that an IT professional must know how to protect information. This is two fields, we believe. Information assurance as one aspect of protecting data. And then a more common term, data security, as another aspect of it. These are actually two different things. And rather than spoiling the fun now, I'll just refer you to, oops, where's the course? the course here. Should we do this first? Nah. We have another course in the curriculum, the 25 course. This is Professor Hoppe, who's one of the assistant directors in the program. This is his field and specialty. He does this on the job. Data security and information assurance. And those are related to the idea of protecting data, but in different ways. I won't spoil the fun now, but you probably realize that, yeah, this is a big hot topic, right? This is a big, we just talked about the gigantic healthcare data breach earlier. Yep, big topic. Username, password. Please wait while we confirm your identity. See, a little hand comes out, takes the wallet. Yeah, okay, they're not funny. Ooh, you know, I hear this consistently also. An IT professional needs to understand effective documentation. An IT professional needs to be able to write concisely and coherently. Sometimes people ask me, wait, what, you want me to write things in this class? Yes, I do. Why? Because you're going to be writing things when you're a working professional. Sorry, it's usually the way it is. Documentation is, there are lots of jokes about it, but in actual fact, good documentation is worth far more than gold in the world of information technology. So yeah, I'm going to ask you to write, read and write. And matter of fact, every course in our curriculum is going to have you writing at least a little bit in it. That's important for an IT professional. A class that will probably really focus on this and some aspects of good documentation and effective writing in technology is the 45 course. This was the precursor to the 50 course I showed you earlier, System Design and Configuration. The 45 and 50 courses taught by Professor Wall, who again has lots of industrial experience in this area. My productivity software turned on me. It keeps crashing my computer, but that's okay because I don't need a computer to do my job. Do you have any assignments that are sort of pre-industrial? Some of these now are becoming extremely, I don't want to say obvious, but you say, mm-hmm. An IT professional knows how to locate information. It's not always what you think, though. A big aspect of that is the concept of networking. And we do have a networking class, the 40 class. Dr. Shao, who works in industry, doing this kind of stuff all day long, is our instructor for that. And networking, although you might not immediately think about it as locating information, once you stop, you say it's absolutely on the core of that. As another example, think of SaaS, software as a service. I'm not going to go to the links. Sorry. Look it up. Software as a service, if that term is not familiar with you, it used to be kind of a buzzword. It's kind of gone a little bit mainstream, and people don't oftentimes use SaaS anymore. But software as a service, part of this whole idea also. Very local area network. That's not truly what VLAN stands for, but see, here's our really close network. An IT professional needs to know how to manage projects. We talk about that in a few other courses, and we actually have a course focused on that idea. We do have a project management course. It's the 55 course dealing with this subject directly. What is the priority of your budget request? Highest of the high. Everyone rated their own budget needs highest priority. It's a mockery of the priority system. Name one thing that everyone would agree is a low priority. Whatever you're doing. Okay, sorry. These only vaguely relate, but I had to keep these in there to keep my interest up. And the other thing that I hear, well, okay, there's probably more than 10, but 10's a nice round number for people. A final thing I hear really consistently is we want future IT professionals to have experience carrying out a complete, real project. Guess what? That's what our capstone course is all about. The 565, H65 course is the capstone experience where you'll carry out a real live project. This course is designed to be taken during your last semester. It doesn't have to be the very last course, but it needs to be in the group at the very end. We teach it on campus every semester, fall, summer, spring. If you look, it's only in the first session, session A. And the reason for that, the course is a little different. It's actually a 14-week course. So we kind of fool you. The first half of the class will meet and discuss some things and get set and figure out what the project's like, talk about the documentation and other things. But then we allow the remaining 7 weeks for you to actually complete the project. Okay. Let's take a break.